Hello everyone, good evening. Today's topic from Accelerate is natural language processing. We are going to do a simple chatbot using Python NLTK package. I would suggest this is going to be a code walkthrough. So just sit back and relax, because if you try to do it along, we might end up getting into errors and then spend a lot of time on that. So what are the topics we're going to cover? Starting with what is natural language processing and a basic or the advanced applications as well, and then a typical steps in applying the NLP, and then we'll cover what's a chatbot, and then we'll go through a code walkthrough. NLP, in short, expanded to be natural language processing, is a subfield of artificial intelligence. It is covered in various scenarios and various applications, the current being customer service areas or just the retail fashions, to the current developments being in education institutes, even training the robots to become artificially intelligent by understanding ambiguous words and several languages and human context and other such things. Why is it in-depth or a very deep field in NLP is that human languages are very ambiguous, and also communication is in several ways in the form of sound, gesture, images, and explosion of data. With all these, what it means is it becomes really difficult understanding the context, and the context differs from person to person, and also there are multiple intents in a single question. For example, if you see the picture put up here, what can I help you with? So this is a bot replying here telling I would like information on loan insurance and cards. So if it doesn't understand the context of it, it cannot reply with the appropriate answer. So here a simple bot is telling I don't know specifically what you're asking about. So what it would give is, it would give multiple things what all that particular question could relate to. So here the example provides card, loan, and insurance. So these are some examples. Moving on, we all know the popular applications like Alexa, Siri, and Google Home. These are all based on speech recognition techniques, some in an advanced manner, and some are simple rule-based applications. So what all can an NLP robot or a chatbot can do is, the pioneer in autocomplete would be Google, who are far more advanced these days compared to the initial period. And we have smart search providers like Klevo, who are doing self-learning by themselves in the e-com industry. And what happens is, by watching how shoppers interact with the search on the store, they just keep upgrading their program to give their relevant results used on the machine learning algorithms. We can also, NLP also does sentiment analysis. This is like a Twitter or any social media activity is very popular these days with NLP. And the most common usage again has become the virtual assistants, where the classic example would be MasterCard using them, or even the simple example to have it as home assistants, just answering any question we have. Okay, coming to the typical steps in a natural language processing. As I said earlier, natural language is very ambiguous and it's a lot of data with data explosion. So the first step is gathering the data, which again has several methods, like just having hard-coded text values or scraping it from the web, and using the inbuilt corpus of any language that they provide. So importing the libraries or using a hard-coded text is the first step. From there on, pre-processing again involves several steps. The first step would be tokenization, where we have to segment into sentences and then words. From there on, we need to move on to filtering out the encoded values or removing the stop words. There could be n number of pre-processing. We'll be covering the basics. Then we go on to stemming or lemmatization. So all these are done because we have to get to a point where the processing has to be minimal. So if we have a huge amount of memory is required for processing the documents, so all these steps would make us to drill down and then reduce the amount of processing. So basically, after the pre-processing is done, what we'll do is send it to a machine learning algorithm. So when we say the steps involved in this pre-processing and machine learning, there could be other type of chatbots wherein we don't require a machine learning. They are called the rule-based chatbots, where we do text-to-text comparisons. So there we would just compare a word with another word. It wouldn't acquire much knowledge. But when it comes to machine learning algorithms, again, there are two types of it. One being a self-learning robot versus the other being a rule-based. So today's algorithm would be a simple one to provide just the context and to start with. But there are many more complex algorithms and researches are being on. Like I said, when there is a chatbot sitting on a training session in a school's environment, it learns quite a lot of amount of words in terms of languages, and then human expressions, and also the context, scenarios, and so many other things. So this kind of environment and this kind of researches are going on, where given all this, still the chatbots or the history started off with Alan Turing in 1950s. But the simple Alan Turing test says that whenever there is a chatbot which is comparable to human, then it passes the Alan Turing test. But so far, we haven't reached that point yet. So a lot of amount of research is going on in this field still, and we are trying to go there. I'll quickly move on to the code and then come back to the explanations. So meanwhile, if you have any doubts, feel free to just message and then I'll get back to you. This code is shared with you in the Google documents. So I'm just running through the walkthrough. The first step is the import of the NLTK package. I've commented the NLTK download as I've already downloaded it. For the first time, you need to download the package, and all the packages required are imported using the import statements. We are going to use chatbot.txt for this exercise. So this is nothing but the Wikipedia page. For simplicity, I've just scraped the text part of it and then put it into a text document. The other way of doing it is we can use the web scraping tool and use the Wikipedia chatbot page. So once you have this as so this is what we are going to use as our corpus. There are many inbuilt corpus inside the NLTK package as well. You can try to create. So the one important aspect of a chatbot is the training set. So whatever is the input we are giving, it would acquire as much knowledge. So this becomes an important step. From the chatbot.txt, we are reading the file and converting everything into lower case for reducing the ambiguity. So the next step we talked about is the segmentation. The send tokenize will split the sentences from the chatbot.txt, and word tokenize will get the words of each sentence. Here I've printed what the send tokens have. So there's the first sentence is listed here, and the word tokens have the words of the first sentence. Then the next step in the pre-processing is reducing the number of words to have less memory consumption and other uses as well. WordNet lematizer is a inbuilt corpus or a inbuilt dictionary in the NLTK package, which has a lot of words. Here what it does is it reduces the word to its lemma. So if we have a similar word occurring 10 times in the 10 or 100 times in a huge data set, then this would mean it could reduce it to just one word. Now going back to the explanation, let's see what is the difference between stemming versus lemmatization. So here the text pre-processing is mainly done for either noise removal or normalization. So normalization will reduce the number of words for us. Noise removal will give better quality of output. So what it means by noise removal is removing redundant text components. There are several methods to do that. Not all of them will be applicable for every program, but we need to make a choice. So here we have removal of punctuations, or there could be tags, URLs, and stop words are words, nothing but like nouns or pronouns, or the words which repeatedly occur like are, in, prepositions, which will not be of any meaning when we do document comparisons, and these are not the important words. So it makes sense to remove these stop words as well while doing our comparisons. The next one, the other aspect of pre-processing is normalization. That's where we come to stemming versus lemmatization. So stemming just removes the suffixes. So when we take up our example here, we see that the multiplicate, multiples, multiply, all that, what the lemmatizer do is it can identify from all of this corpus that our lemma would be just multiple. So it identifies the root of the word. Okay. Going back to our code. So what this does is from our chatbot.txt, we have removed the punctuations or the stop words, and then we have removed the we have identified the lemmas from using the lemmatized function. So these are inbuilt functions. You can read up for more documentation. Next we come to the core function of the chatbot. This is a hard-coded message which we give. So initially we are trying to see if the user's message have any of the greeting words like hello, hi, or what's up, and so on. So this is something like a rule-based chatbot, the first function alone. So what we are doing here is, if there is a greeting word, so we are just replying back with a greeting message. So we just compare the words and then give a greeting response. We have an array of words which we check, and then we give a response accordingly. So the next part is the training part. You're going to use the machine learning feature extraction and the machine learning algorithm to do this. So let me go back. Yeah. So this is how our chatbot works. We have a set of documents or our corpus. Then we did the tokenization and the pre-processing, where we remove the stop words and lemmatization. And then we have to do the feature engineering part, where we have to compare the user's input with the set available with us, the corpus. Here we can do Bagofwords or TF-IDF. These are the algorithms available, which I'll be explaining. So with this feature engineering set, we just have to pick one of them, and then after comparing, we already have our model. So we have to build that model. After we have built the model, what we are doing is trying to take the user's input and then fit it into our model and evaluate it and give a response. So this is the flow which our chatbot follows. In general, coming to the anatomy of a chatbot. So a chatbot, as we saw, could be designed for mobile apps or any chat applications. It could be for web pages, and several other trending chatbots are coming up. Even the ones with the smart shopping assistants in the e-commerce side, they are trying to incorporate the chatbot with the robots to give a pleasant experience for the customers. So what it does is, here it takes a human input, and then it has some knowledge which we say as the corpus, and it also has some rules and logic which are given, and it compares with the rules and the logics and does some machine learning from the algorithms we train it on. And then this is all in the chatbot server. After that, the response gets back to the user in the form of from wherever they are calling the chatbot. It could be the application or the mobile app or so on. So this is a simple anatomy of a chatbot. Now, so let's get back to the functions. We are defining the response function here. Here we are going to use the TF-IDF method and the cosine similarity. A little bit of background before we see how it responds. So feature engineering using Bagofwords. What it does is, it lists unique words from a vocabulary. For say, the given example here is a text which says, I love this movie, it's sweet, and it's a review about a movie. So what it does, this Bagofwords, it simply picks up each and every word and then does all the after the pre-processing and removal of punctuations and all that, we just have the words alone from this text. And it would say there could be several representations. Here what is given as a frequency. It could just say, the Bagofwords can say that if a particular word is present in a document or not, a 1 or a 0. In this context, since we have the frequency, the biggest disadvantage of Bagofwords is that it ignores the context or the meaning. This is why the other algorithms came up, like the word embedding, the glove, etc. So one method of doing the Bagofwords is frequency inverse document frequency. So TF-IDF, what it means. Let me explain this with a simple example. So TF is the number of times a particular word appears in a document divided by the number of terms in the document. And what happens is TF, earlier they were using TF to find the Bagofwords, just the frequency. But then when you have longer documents, it gives more importance, since the number of times a word appears in a document will be more. And this is not what we want. This is not accurate to compare the documents. So then they came up with inverse document frequency. What happens here is, when there is a word that appears frequently across documents, then it is penalized, in the sense that highlighting words that are distinct and having the adverse effect of it. So, for example, let's say in document 1 and 2, here below, it says this is a beautiful day, and document 2 says this is a beautiful night. What happens is, beautiful appears in both documents. Say in document 1 it appears 2 times, and in document 2 it appears 1 time. So when we compute the term frequency of beautiful in document 1, it's 2 out of 10. So the 10 is just the number of the total count of the terms. And for the inverse document frequency for beautiful is 0, which is log of 2 by 2. Similarly, when we find the term frequency for day in document 1, it is 5 out of 10. And the inverse document frequency for day is log of 2 by 1, which is 0.3. What we see here is, and yeah, I'll complete. So the term frequency TF-IDF for beautiful, 2 by 10 into 0 becomes 0. For day, it becomes 0.15. Out of these two documents, even though the frequency of the occurring words are more, the more important word is day and night, which differentiates the documents. So the TF-IDF accurately identifies that beautiful is not the important word, and we'll get that day is what is a distinguishing word. So the words with I TF-IDF means a signature word. So that's what we are trying to find with the TF-IDF. Okay, cosine similarity. I found this article interesting because it compares three of the two leading Indian players, and it describes the cosine similarity between the two articles. Here the articles considered are Wikipedia page of Sachin Tendulkar and wiki page of Dhoni, and a short extract from the Wikipedia page of Dhoni. Here, if you see, this is how the output of a cosine similarity will be, like a matrix which is called a sparse matrix. It's just in a visual form in 3D space. The same three documents are put up here. So the first document was Doc Sachin, and the second one was Doc Tony, and the third one was Doc Tony small. Here are the documents. If you see, we can compute the similarities in different ways. Here we are trying to use cosine distance. There is another thing called the Euclidean distance. How do we compare two documents, and what are the parameters to say how similar they are? So that's what is explained in this visual. Here, if we see, the cosine similarity is nothing but the difference in angle between the two documents. So it's quite obvious that the document Tony and document Tony small are similar. Going back to our code, so what we have tried to do is, this user response is from the user. We have taken the user response, and then this TF-IDF will calculate, it will give a sparse matrix of the similarity between the user's response and our corpus. It is the corpus is our chatbot.txt, which is taken from the Wikipedia page. So here what we are trying to do is, we will take a user response and compare it with our corpus. Here this is the function fit transform, which will do the learning part for us. This is the model training part, and then we are using the cosine similarity, and this will again give us a value, a matrix for the sparse matrix, which would say the similarity between the word and the given corpus. So what it means here is, we have taken the user response and added it to the send tokens, and then send tokens is sent to the transform function. So the entire set of corpus, the sentences along with the user's response, is all sent to our machine learning function, so that we are able to train the model. Now here the TF-IDF of -1 is the last element which we added, which is the user response. In cosine similarity, what we are trying to find is finding the similarity between the user response and already available corpus. Then we are doing a sort. So why we are doing a sort is, we can eliminate the last element which we added. So once we do the sort, and then we'll just remove the user's response from it, because it will always have a matches exact match. So after that, we are just saying, if it doesn't find any match at all, then the chatbot would say, I'm sorry, I don't understand you. If it finds a match, then what it will do is, along with the robot response, it will give the sentence which exactly matched from our corpus. Now let's try and run this. So when we run this, what it's saying is, it's a hard-coded statement which says, I will answer your queries. I'm just saying hi to the chatbot, and it is picking up one of our greeting responses and says, I'm glad you're talking to me. The next thing we do is, I'll give some more inputs. Like, since we have picked up the chatbot Wikipedia page, so I'm going to ask, what is a chatbot? So as you can see, it's not so accurate what the answer it has given, but here the point is, we are just trying to see how a simple rule-based chatbot would work. What it has picked up is the word design, and since this line has a lot of design which it has found to be relevant using our algorithms like TF-IDF and cosine similarity. So this is the best match it can find using this machine learning methods. How can we improve is by using a different algorithm for machine learning. Also, in every step there could be improvements like the pre-processing, and if we use different set of corpus, not from just Wikipedia, and if we have 10 different documents, this is going to improve the accuracy. Okay, so next thing is the response function. So this is the function where we said this is the starting point where the chatbot is saying I will answer your queries. Then we take the user's input, and these are simple comparisons where the user's response is compared to buy. If it's a buy, it will just end the chatbot. So these are just rule based. And if the user's response is thanks or thank you, it is going to say even this is hard coded for greeting. If none of them are there, then we come to the next part where it is actually we are calling the response function. So this is where we actually do the machine learning part, and these are the areas which require different learning approaches, models and trainings. There could be several other ones which can improve the accuracy of our chatbot. So that's it. So we are done with the simple chatbot. Are there any questions? Okay, what is the purpose of putting flag equal to true? I'll just check that. Okay, this flag equals to true is required to run this chatbot in a recursive loop to keep it running. That's the purpose. When it becomes false, we just end by saying thanks, you're welcome, or so. When we want to run it, then we use again, because we are checking here if flag is true. Okay, a word of caution. So here we all know maybe the story of Tay, the chatbot, which was developed by Microsoft in 2016, and it was shut down in 16 hours, less than a day. This was because it entered into controversial statements, and so it is really important to train our chatbot on various scenarios, and diplomatic responses also to be included to not to get into trouble. So that's one important aspect. So it would have, the scenario would have been avoided if they had expected all the controversial statements to appear as well, and then train their models on that as well. Then it could have been much better. So that's a word of caution. Yeah, why we use cosine similarity. Okay, let me take up the PPT again. So when we saw in this example, in our chatbot we can even use Euclidean distance, but then cosine similarity is proven a little bit better. So here we use this. For other examples we need to make much more research before using it. If you see this one, the Euclidean distance between these two, the document Dhoni and the document Dhoni small, and the other two between Sachin and Dhoni, are obviously, from even that aspect we can say that these two are, I mean, the Dhoni small and the Dhoni large documents are similar when compared to the other two documents. But then in terms of the cosine similarity, what we end up is easier way of identifying visually with the functions available, because all these could be projected in a 3D space, and then also it is just apt for our particular example. So that's the only reason. But we can use any things and we can just try the accuracy of the program. So if there are any more questions, or if the code has to be run, or if you are willing to have a separate session for setting up NLTK, running the code, and one-on-one interactions, we can have one more session. Just drop in an email or just give us a chat message so that we can continue in a next session, a Zoom session, which can be arranged in the due course. Yeah, it can be reviewed on the YouTube. It'll be saved. Just subscribe for our channel and send in an email, or just next session is coming up next Thursday. The topic will be posted soon on our page. I'm giving the email ID to send the mail to. For any questions or any installation problems or anything around the code, just feel free to email. And if there are enough signups for the one-on-one sessions, we can take it up. You can email to my email ID. Okay, assuming there are no more questions. Edmund, I didn't understand the question. What is it? Okay, then thanks for watching.